Hi, this is Kyle Knotek, partnered along with Zach Kruljac, and today I'm going to be talking about our final project. So I'm just going to go ahead and start in the main class here. And as you can see, everything is pretty much based off of previous projects, still using the same code. This one in particular is based off of PA5, so all the texture implementation is there already. So we can see here, basic rundown just through how the program works. It creates the engine, initializes the engine, then runs the engine, and it also, in the engine class, it creates the window and graphics. So we can see here in the window, pretty much everything's the same, nothing's really changed. It doesn't really need to. But here in the graphics class, we can see a lot of things are different. Actually, I will go ahead and show engine first because it's a little bit easier to explain for now. So as you can see here, this is where a lot of the things are different. Here we do have a get cursor position call with a reference to X position and Y position, and these are just floating point values to determine the position of the cursor on the screen. And this right here is a little bit of math to make it so the cursor is not calculated from the top left corner of the screen up here, because obviously we want it to be centered in the window to make it more easy to use for the mouse movement. Over here we have the basic controls, all the key bindings for different things. So here WASD changes the velocity values on the X and Z axis, and we can also see here pressing space and pressing control moves the spaceship up and down. And then over here, when the user presses shift, they will engage a sort of hyperdrive mode where the player will shoot forward at a very high speed here, 300. And over here, we can see that there is different calls to set the rotation of the ship according to the X position of the cursor. Over here is a value of the X position divided by a very large number to sort of limit the speed that the angle will change when the cursor is moved. If this wasn't here, the ship would go crazy and would not be controllable at all. This one is dividing by a greater value to limit even further the movement of the mouse while the player is engaged in hyperdrive mode. As we can see here, we did implement a stop all momentum. We decided to not have momentum because it was sort of hard to control, and it was very annoying when the player would keep moving and you had to press X every time. So we just made it so when you let go of the keys, the spaceship will automatically stop. So here, this right here is how to engage the planetary view mode by pressing V. And over here, by pressing B, it disengages the planetary view mode. And the planetary view mode is made by a Boolean value set in the camera class. The camera class is actually what determines the exploration mode and the planetary view mode. So next I will go to the graphics class. Over here, as you can see, things are not kind of saying that they are valid just because I restarted Visual Studio and things are not properly loaded because I did do a pull from the GitHub. So just ignore that for now. Be assured it works, as I will show in the video later. So over here are all of the values that determine the orbits of the planets and moons. As you can see, different values here. Saturn is 800 units away from the sun, which is pretty large, but with the hyperdrive mode, it's not really a problem. Over here is all of the transform location updates, and also the hierarchical updates, which is done in sort of a clever way. It's not using a literal stack in a sense. It is using a stack in the metaphorical sense where it stores the value in a variable and transfers that variable into the hierarchical call of the moon. So here we can see Earth has a transform matrix, and what it does for the moon is take Earth's transform matrix and multiply it by the moon's transform matrix, and that makes it possible for the moon's orbit to be based off of the Earth's position. We can see that for all the moons, Mars, Deimos, Phobos. We can see all that stuff here. Jupiter and all its 4 lovely moons, Ganymede, Callisto, Europa, and Io. And for Saturn, its ring and its big moon Titan. So, yeah, I will talk about lighting in a bit. I will go to the camera and show off how we did the mode switching. So here actually, I'll go into the graphics real quick. So here we can see I created all of these transform matrices, and for each planet it gets the transform model of it, and then gets all of the attributes from that, and then updates the camera class. So we can see here all of these attributes here are the transform positions of the planets. And how the collision detection works is it checks if the spaceship translation parameter is within a certain range of the planet. So here we can see it's 30 units away, and it sets a Boolean value if it's colliding, and then over here the view state is determined whether the player is pressing V or not, and then it changes the state Boolean value. And then over here, if the state Boolean value is 1, this line right here determines the looking of the planet. And this one right here, if the change state is 0, which means the player is not pressing V, that means, or actually it's if they're not pressing V, or if they press B, that means they look back at the ship, which is this line of code here. So back in graphics, we can see all the lighting here. Well, actually, in the light class, we can see all of the light, ambient, diffuse, specular, and global ambient are set with the graphics. We see all of the lighting properties here setting up with the vertex and fragment shaders. And then here, all the materials are applied to each celestial body, including the skybox and the mesh. Obviously the specular, shininess, ambient, and diffuse values are different for the sun as opposed to the skybox, as opposed to planets. So over here, this is for the skybox. Its material ambient is slightly lower, so the stars won't be as bright. And then over here for Earth, for all the planets, we have the material ambient is 1, because unfortunately our point lighting system is not entirely functional. So right now we're just relying on ambient lighting, but we still think it looks good to get the message across. So as we can see here, all the updates for each planet, and then all of the attributes and error codes for our shaders. And then here for our shader class, we can see here is our vertex shader, and then here is the fragment shader. And yeah, just to show that it still runs, and yeah, here it is. So thank you for being with us, and thank you for having a fun semester, and I hope you have a good Christmas.